You know, sometimes a feature comes along that's designed to make everything faster, better, more efficient. But what happens when that same feature accidentally creates the perfect storm for attackers? A flaw so bad that a single simple request can give an outsider total control of your server. Well, that's the story of React to Shell.
Okay, let's just start with this number right here, 10.0. On the CVSS severity scale, that's as bad as it gets. I mean, there is no 10.1. This is maximum criticality. It's for vulnerabilities that are not only devastating, but also incredibly easy to exploit. Officially, you'll see this as CVE 2025-55182, but everyone in the community is calling it by a much more fitting name, React to Shell.
And this isn't some fringe, theoretical issue that only affects a handful of servers. Nope. Our recent massive scan of cloud infrastructure found that a staggering 39% of environments are running code that's vulnerable to this attack. 39%. That means there's a very, very real chance this applies to you, or your company, or services you use every single day.
But here's the part that should really send a chill down your spine. This isn't about a developer making a mistake. It's not about a bug in your code. This is a fundamental flaw baked into the default setup, the very setup that developers were told was safe and ready for production.
So here's our game plan. We're going to break it all down. First, we'll dig into the critical flaw itself. Then, I'll walk you through exactly how the exploit works, step by step. After that, we'll look at who is actually using this thing out in the wild. And most importantly, we'll finish with a clear, actionable plan to get your systems locked down.
All right, let's start at the beginning, with the technology at the very heart of this mess, React Server Components. This is a classic story of good intentions gone wrong, a feature that promised a new era of performance but accidentally opened up a security nightmare. So, for anyone who's not deep in the weeds on this, server components are a newish way of building apps in frameworks like Next.js. The big idea is to do more work on the server. The server runs some code, then it serializes the result. Think of it like freeze-drying food, right? It packages it up into this compact format and sends it over to the user's browser. This way, the user's phone or laptop has way less work to do.
And this right here, this slide perfectly shows why this changes everything for security. In the old world, most of the logic ran on the user's browser, which is a pretty locked down environment. But with server components, all that logic now runs on your server, your trusted backend. The attack surface has literally moved right next door to your databases, your API keys, all the crown jewels.
And that brings us to the root of all evil here, insecure deserialization. Remember that freeze-dried data packet? Well, deserialization is the process of rehydrating it, unpacking it, and rebuilding it on the server. The huge problem is that the server just blindly trusts that the packet it gets from the client is safe, and it's that misplaced trust that opens the door for the entire attack.
So, how exactly does an attacker abuse that trust? Let's break down the incredibly clever technique they're using. It's being called the fake promise exploit.
Okay, get this because it's both brilliant and terrifying. It works in 4 simple steps. In JavaScript, there's this thing called a promise, which has a special property called .then that runs code when a task is done. So, first, the attacker creates a malicious object. Second, they stick a fake .then property onto it. Third, instead of that property being normal, they point it to JavaScript's global function constructor. And finally, when React gets this object, it thinks, oh, a promise, I need to execute the .then part, and boom, it does just that, running the attacker's code directly on the server. Game over. That's remote code execution.
And I really need to hammer this point home. This is not a drill. This isn't some proof of concept in a lab. This exploit is out in the wild, and very smart, very motivated people are using it as we speak. This is happening right now. Threat intelligence is showing a whole menu of nasty payloads being deployed. We're seeing sophisticated backdoors like KSwapDoor that give attackers persistent access. We're seeing crypto miners like XMREgg that just hijack your servers to make money for someone else. We're seeing scanners designed to sniff out and steal your AWS and Azure cloud credentials. And maybe worst of all, some of these payloads are being traced back to state-sponsored groups using this for high-level corporate espionage. Okay, so that's the bad news. Now for the most important part of this whole thing, your immediate action plan. These are the exact steps you need to take to protect your servers, starting today.
First things first, and let me be absolutely crystal clear, there is no clever workaround for this. No magic firewall rule. The only way to fix this is to upgrade your dependencies to a patched version. That's it. It is completely non-negotiable.
So here are your 3 critical to-dos. Number 1, in your project's terminal, run the command npx fix-react2shell-next. It'll help automate the updates. Number 2, you have to assume you've already been breached. That means you need to rotate all of your secrets, API keys, database passwords, environment variables, all of it. And number 3, scan everything. Use free tools like react2shell-guard to check your code, your live sites, and even your build pipelines for any signs of trouble.
You know, when you zoom out, this whole mess has exposed a really painful truth about the way we build software today. We've been building on top of all these amazing frameworks, just trusting these abstractions to keep us safe. But this vulnerability proves that the clean line we all thought existed between the client and the backend, well, it's been shattered.
And that really leaves us with a huge question to think about. In our constant, relentless push for more performance, for faster load times, and better user experiences, have we accidentally traded away security for a fundamentally broken model of trust? That's a trade-off we're all going to have to seriously